Okay, so that should now be recording. It says recording pending. What does that mean? Oh, there we go. Okay, so I'm going to start from where I started from again, for the benefit of now the fact that we are now recording this, and we'll go through the paradigms. So started off with procedural programming, and procedural programming, as I was saying before, is a way in which we can program that requires minimal user input. Excuse me. It's pretty simple in terms of how it works, because it will start off reading the top of the code, and it will just run through the code without particularly. Oh yeah, of course it says Stephen on it. See the groupie muppet. Because it doesn't particularly do anything complex. So it just reads the code, takes what the user has put in, reads the code, puts it out. The absolute best example going of procedural programming is when you press the power button on your computer or your device, and it loads up to the point where it loads the operating system. From that first button press up until the code for the operating system kicks in, there are no instances of user interaction apart from the one specific point where the startup routine, the startup program, is listening for a key press from the user to enter the BIOS and enter the BIOS settings. But that's as much input as the user actually has when we start up a computer. It's the simplest bit of coding to learn, because we don't need to worry about how we get user input. All we need to do is give the instructions to the program for what happens when it is started up and it has been given whatever data it is using. It's also really good for anything that runs complex calculations using different data sets, but the calculations themselves don't change. So if you're doing some form of analysis of data or statistics, having some form, and you're obviously creating a program specifically to do so, as opposed to building a spreadsheet that will do the calculations. Procedural programming would be the best way to do that, because you put all the constraints in, you put all the standard static variables in, the stuff that's not going to change. You set up the methods, you set up what it is it needs to do, any calculations it needs to do. The user inputs the data that they want that analysis to be run on, and the program just goes dunk through all the steps to the point where it then stops and goes, here you go, here's your output. Now, obviously the benefit with that is it's nice and simple. The main drawback of procedural programming, or one of the main drawbacks of procedural programming, is the lack of user input. It's very fixed, it's very rigid, it does what it does and that's it. You also have to type all of the code out, and if you need to repeat a piece of code, you have to retype that piece of code. What you can't do is write one piece of code that does the same thing and apply that to multiple different circumstances, because all it is doing is it's starting at the top of the code and going straight through. Pretty much every programming language that exists will write procedural code. Up until the point in the work that we did before Christmas, up until the point where we asked the user to choose the question, we actually were writing a procedural program. we put the code in, you ran the program, and up until we added in getting the user response, all it did was run through that set of instructions to the point where it displayed the question. There's not really a vast amount more that you need to know about procedural programming. It's easy to learn. It takes tasks that would be repetitive and does not require a lot of input once the initial data has been set, and makes them easier to do and to run, and cuts down on man hours performing those types of calculations and those types of steps. But it is what it is, it does what it does, and that's about it. If you wanted to add any additional steps to it, you would have to edit the program, add those in, and they would then be static, set in stone, and would run when they get to them, whether you need them to or not. And because it runs in direct order from the top to the bottom, it is quite difficult, or it can be quite difficult, to find errors in that code. It's not so bad using an IDE or an integrated development environment like Visual Studio is, because that will highlight errors. So it does make it a lot easier. But if you're not using an IDE and you're doing it in a bit of an old-fashioned way, I remember when I was at school, my dad was doing computer programming, and they actually at that point, to find errors in the code, because it will just run through and it won't tell you exactly where the error is, they actually had to print out pages of code and sit and manually go through the code. So finding errors in a procedural program can take a very long time in which to actually do. If you understand what I've just said with that, please put yes in the chat. Obviously, I'll not be expecting a response from Jack because he hasn't heard a word I've said. So if you understand what I've just said about procedural programming, please type yes in the chat. Okay. Oh, there we go. I was about to say, if anyone is alive, please type yes in the chat, but then then all the yeses start coming through, so it's all good. Scared me for a second. I hate technology. Ooh. Okay, so I think that's pretty much everyone. 2, 3, 4, 5, 6, 7, 8. Who's not responded? Oh no, who's not responded? We've got girls. Lewis, we've got Declan, Freddie, we've got Kieran. Of course, I'm counting Jack, aren't I? Idiot. Please note, math skills, not my strong suit. So that's procedural programming. Moving on to event-driven programming, and there's a reason I'm doing these in this order. So event-driven programming allows us to take a program and modify what the program does based on the input from the user. Now, there's one thing that I'm going to say and get out of the way first. You will come across articles, stories, dictionary type entries on things like Wikipedia, which I know have a proper name, but I can't remember what it is, so they're dictionary type entries for the moment, that will talk about objects in event-driven programming. The objects in event-driven programming are not the same as objects in object-oriented programming. And it is very easy to get mixed up and to get confused. And I usually get at least one person every year. I usually get at least one person every year that starts talking about objects in procedural programming being like objects in object-oriented programming. In procedural programming, whenever you come across the word object, it is talking about something that the user will interact with. So it's talking about things like a button or a drop-down list. It's not talking about objects in the same way as OOP. In OOP, an object is a specific representation of something. So it might be a specific book or a number of specific books that are all representations of a single book in the program. Does that make sense? Let's just put a divide in there. If that makes sense, put yes in the chat. Because I do need to make sure that you know the difference between when they talk about objects in event-driven and objects in OOP. Right, good. So event-driven programming is based on the user interacting with the objects that I've just been talking about, things like the buttons, drop-down lists, and stuff like that. And what the actual programming language does is it listens out for the user's interaction. It listens out for the user typing. It listens out for the user doing things like pressing the enter, clicking a button, selecting something from a drop-down. And it makes changes and runs certain parts of the programming based on what the user has done. This does make it more complex to do than the procedural programming, because at this point we also have to consider whether or not the user is going to work out what button they need to press. And we have to start taking into account that we need to start getting getting the input from the user and changing what the program does. What we do have in event-driven is the ability to we have the ability to introduce modularized bits of code, and to take bits of code and put them so that, depending on what the user has entered, different bits of code can be displayed. And the event-driven programming is what we did before Christmas, after we added the user interaction for selecting the question. So if I open this one, so this is a version of the app that we did before Christmas. Now, if this was event-driven, what would actually happen? It would start at the main, not event-driven, sorry, procedural. It would start at the main method. It would go to the greeting method. It would get to there. As soon as we've done that, and we've got this console.read line that we use to get the name of the user, that's stopped being a procedural program and became event-driven, because it gets this far and then the user has to give it an input. Now, the input at this stage just tells the program to carry on down to here and go to the question. So it doesn't do a massive amount of event-driven. Then runs through the question, and we set, in the case of how I coded this, we set the choice. we set the choice, which we pick up from the user. User presses enter, and that choice that they've made is saved. It then goes on to answer. And this is where we can start to really develop how a event-driven program would start to differ. Because what we've got, or what I've got in here, a switch is a different way of writing an if statement. So we used if the user had entered A, if the user had entered B, and else in your version of the program. I've used switch in this one. It's just a different way of approaching an if statement. It does the same thing. This would be if choice equals A, if choice equals B, and else. Else if choice equals B, else at the end. But what we can do with this, depending on what the user has selected, in this case, we've just got to display a couple of lines and go and run this restart method. But we could go to a restart method in this one. In this one, we could send it off to display the save option on the interface. This one could go and be a button that allows us to close the interface or close the program. And we could start breaking this out. And start breaking it out into a number of different methods. And anytime someone presses the particular button or types a particular command in, we can start going through and picking up all the different key presses on that. So it allows us to have different modules of code that will accept user interaction within those objects or within those modules. What it doesn't allow us to do is create groups of objects that have the same properties and access them a bit like we would access a table in a database in Unit 18. But what it does is it allows us to go back and pull up a bit of code depending on what the user has pressed. However, event-driven programming does come with a caveat. And the caveat that comes with event-driven programming is that you can't reuse the same piece of code for multiple things. So in event-driven programming, every single one of these buttons, say, across the top of this screen, I wouldn't be able to use the same piece of code that changes the highlight color and changes the text to bold. I wouldn't be able to reuse the same piece of code and just change the word that is being shown on that. Every single one of these, despite the fact it does the same thing, well, with the exception of one that's selected, it does the same thing as you roll over them, it would still have to have that code repeated for that one object, or that one, in this case, the one tab on this menu. It is reasonably easy to develop in terms of complexity. It's not as easy to develop as a procedural program, but it is easier to develop than something that is object-oriented. It is, however, repetitive, and it does make error checking that bit more difficult because you still have a lot of code that you would need to go through. The same as you do for same as you would do for procedural, but actually amplified, because each of the objects that the user interacts with in event-driven programming will have to have its own piece of code applied to it. If you have understood what I've just said about event-driven programming, or you think you've understood it, or you've understood it enough so that if you were to go back and look at it again, you'd get it, please put a yes in the comments, or something that resembles yes. Okay, I've got 7. I'm missing a person. 8. Okay, good. So now we get to the complicated programming paradigm. And you will notice like random scribbles that will appear. I will show you those random scribbles in a separate bit because you're not going to understand it going off of, you're not going to understand that diagram as it is there. So I will go back through that in a little bit. So object-oriented programming, it's most complex, but it's also the most flexible of the programming languages. It incorporates procedural, it incorporates event-driven, it will get user input, you will be able to do code with buttons, drop-down menus, and so on. It runs from the top to the bottom, it will jump around depending on what methods you've called, or what methods the user has selected. So it still does all the same things as procedural and event-driven do, but now we start to be able to reuse bits of code, and we start to be able to reuse the bits of code for things that aren't the same, but have a similar purpose. And the example that I use for this, or the example I have been using for this, is the process of looking at a book. Or rather, I use books as my example. I think it's probably going to be an easier way to say this. So, all that disappears. Right, blank screen. Excellent. So let's start off with a bit of a question. If you think about a book, what things do all books have? So I'll give you an example. All books have a title. What else do all books have? They all have a title. They have a blurb, index, yeah. I know exactly what you mean by blurb, and I also know that it has a technical term and I can't think what it is. What else do they have? Think even more simple than what's inside the book. Yeah, pages, chapters, potentially. What else do they all have? Who writes the books? Yeah, authors. They all have authors. How do you get from what the author has written to the book that you can pick up and buy? What is the name for the group of peoples that do that part of the process? If anyone knows. I'll give you a hint, it begins with a P. Publishers. Good. So we've got, I'm going to stick with the word blurb, just because I like it. We've got blurb, index, pages, cover, yeah, good. I didn't see that one. Chapters, author, publisher. Okay, and what can we do with books? So what actions can we perform with books? You've got a book in front of you. What can you do with the book that's in front of you? Yeah, read it. Good. Yeah, open and close it. Anything else? Yeah, I'm open to slightly more. I'm open to slightly wider uses of books as well as just reading them. Yep, good. So we can turn a page. Don't abbreviate. Yeah, we can use them as a doorstop. And I'm going to throw one into a mix because depending upon what book it is, we could actually burn the books. So I'm going to throw burn into the mix just to add a bit of anarchy into today's lesson, because why not? So there's quite a lot of stuff there that we can do with a book and quite a lot of properties that books have. And what that would actually give us in this case is something called a class. And what a class does in object-oriented programming is it gives us a template that we can use in order to make sure that we have objects that have all of the different variables and attributes available to them and all of the same methods. So in the class, we would have variables of blurb, index. I apologize for mouse writing. Don't know why I don't type this, but yeah, it's more fun doing it this way. Pages, which I shall abbreviate. Cover. I'm going to head down slightly. I'm going to skip chapters. I'm going to go straight to author. With a H in it, preferably. And publisher. And we'll have read as a method. So read as a method, it's an action that you can perform, and we show that by putting open and close brackets after it. Read will have open, and we'll just put doorstop to keep this short so you're not watching me trying to write with the mouse. Because I do appreciate that that's probably quite painful for you. So that would be a class that we would call book that would have all the code in it to hold all the different types of variables and have all the code in it to do all those different methods. And that would be a class. From the class, we can then create the different objects. So we could have book 1, we could have book 2, we could have book 3. And what each of these different objects are, or contain, is the information that fill out the variables and the piece of code that tells it to run through the methods. But all of this bit here, apart from the actual variables themselves for the individual books, is held in the class. So just to give you an example, I've got a book in front of me. It's got blurb on the back, which says stuff about have you always wanted to learn programming. I haven't put title on there, which is a bit silly. Title of the book, Learn C# in one day and learn it well. The author is someone called Jamie Chan, whoever that is. It's published by, who's this publisher? somewhere in here there should be a page that tells me who the publisher is. LearnCodingFast.com by the look of it. Apparently the publisher is Learn Coding Fast, because I can't see anything else on there at all which would tell me it was a different publisher. So those would all be the variables that might be held in, say, the book 1 object, but would fill out these variables here and would be assigned to these in that one object. And just to give you a sneak peek, let's do this the easier way, instead of me trying to navigate through my file system. There we go, let's have this one. Just to show you what that actually might look like, this is the code. This bit here is the code that runs the quiz that we've done. And this is it. This is the code that runs the quiz. Underneath that, this bit here has all of the information for the questions. So every single bit where I've got new quiz is the start of a new question, and they all have variables that have been set for the question text, the answer text, what is being entered for the answer, what the correct answer is, and what answers are being displayed for a 50-50. And that goes through all of the 10 questions that are in there. But nowhere in this code have I set the variables for showing the data types for each of these variable names. And that's because all of these are held in a class. And this is the class that they are held in. So we've got the question text, answer, answer text, what the correct answer is, and the 50-50. We've got a variable to hold the answer from the student. We've got a variable that we've set up called score. So it says how many, we can say how many out of 10. And this code here is the code that runs for every question in that quiz. If we were doing this as an event-driven program, all of that code that is in this class, all of this code in this class would have to be with every single one of these objects. So that one piece of code in an event-driven program would have to be repeated 10 times. So that's what it would look like. And I mean, I've got the question banks in my code for my main part of my program as a separate method. But actually, you wouldn't need necessarily to have it there. You could have it in its own C# script. So I've got the class in one script, I've got the program in another script. So you could actually have all of these information for the questions held in its own C# script as part of that program. You can actually call in and set up documents that hold the questions that you just load from a text file. And it will load those questions in from that text file every time you run the program, which does make it a lot easier to set up and change questions that are out of date, incorrect, things you want to take out, things you want to add, things you want to improve. So that's what a class and an object would actually look like. And what you have with this here is the encapsulation that we talk about in object-oriented programming. All of these objects in this class are all held together in this nice little bubble. And what we can actually do is hide them in this bubble and make it so that different parts of the program and the user can either make it so that they can either see or not see, or edit or not edit any of these variables or methods. And we can do that by setting them to either private, which means that they can be accessed in the class only. Oops. Or we can make them public. That didn't work very well. Which is able to be read by the program able to be read and edited by the program, or read and edited by the user. And that's what the process of encapsulation is about when we're talking about OOP. Because we can set these things up and we can give all of the classes their own pieces of code and their own code files as part of a full project, or full solution as they call it, like I've got these two here, doing whatever it's doing. Oh. It makes error checking a lot easier, because now I only need to check this bit of code once for all 10 of the questions. And if I have an error in one of my questions, so say I missed a semicolon off the end, I can work out where it is, because it will only run if something from that particular class is being used. And I haven't got anywhere near as much code that I need to go through to find where that error is as well. So that is error checking and encapsulation. So let's have a look at this. Let's have a look at this concept of inheritance. Now, we talk about inheritance a lot in fact, actually, hang on, before we do that, if you understood what I've said so far about OOP, type yes in the chat. If you haven't understood it, ask me questions about the bit you haven't understood so far, because this is the most complicated of the programming paradigms. So if you understood it, type yes in the chat. If you didn't, ask me questions about what you didn't understand. Okay, good. Well done on that one. So let's have a look at inheritance. And to look at inheritance, we actually need to go a step back, because inheritance comes across on multiple levels. So we're going to take a step back from the books for a minute, and we're going to talk about being HMV. So we are HMV. Now, I can't actually remember, I don't think HMV actually do sell books, but we're going to pretend that HMV sells books. What else can you buy at HMV apart from books that you can't buy and we're pretending you can? CDs, yeah. What else? Vinyl, good. DVDs, yeah. You can buy random little ornaments and gifts and stuff. Yeah, good. Games, excellent. So we've got quite a big variety of stuff from HMV. So we're going to keep the books in there because I use books as my example to start with, even though I don't think they actually sell books at HMV. They might sell a small selection, maybe. Can't remember anymore. It's been that long since I've been in HMV. So books, CDs, DVDs, and vinyl, games. So we'll stick with those ones. Now, if we were to take all of those and all of the bits that come into it, what do we actually have? If you were making a system to sort through all of those things, to organize all of those things, and see how many of those things we have, what is the name that begins with S that all of those things would fall under? Anyone think? And put in the chat. Yes, good. Good Arthur, good Maya. Stock. So we can have a class called stock. Because what things do all of those items have in common? You're in HMV, you're looking at DVDs, they are sold. Okay, that's an action, but yeah. What else do they all have in common? Yeah, they all have a title of some sort or a name. Let's change it to name for the purposes of this. Yep, price. You might actually have the amount in stock as well. And what we've already got sold is something you can do with them. But what else can you do with them? The store can sell them, but what if you walked into HMV, what could you do with all of those items apart from buy them? Think really, really simple. Yeah, you can use them, not usually in the store, but I'll add that one in. But even more simple, before you use them, before you buy them, what do you do before you even buy something in a shop? You go into the shop and you, something that begins with L. Yes, Lewis, you look at it. Good. You can look at them all. They're there, they're right in front of your eyes. So if we were writing a program for shopping at HMV, I come back to here, should actually possibly left myself a bit of space there, which I didn't think about, but never mind. Can I select all of this stuff? Not if I do that, evidently. Oh, I've got most of that. From that green line. Oh, for crying out loud. All I want to do is move this stuff down. Can't move this stuff down, can I? Can I? No. That's massively irritating. Okay, just gonna move the books up for a little bit. Come back to this now. So we've got stock. Apparently I'm now writing in green. Oh well, whatever. And in the stock we have the name, we have a price, we have the number in stock. So let's just go no in stock. That we can view, which has the open and close brackets because that's an action. We can buy, and we can, let's put use in there as well. And that can be done to everything in stock in HMV. Once we've got that bit, we can then start looking at the different items. So we've already had the books. Now we don't need the title now. because we've got the title in the name in this stock. We do need an author. We do need maybe pages. That's supposed to be an S at the end of that. Just kind of roll with it for a minute. We do need pages. We do need the author, publisher. I'm going to abbreviate to pub. And let's have read as one of our methods that only applies to the books. And what's one of the other ones? Well, doorstop we could actually probably use just about anything as a doorstop. Whether or not they would be an effective doorstop is a different question. So there is the class for a book. So now we've got stock, which has all of this information. And then related to the stock, we have the book. Now the book will inherit all of these variables from this stock class and add its own variables and its own methods to what is already in this stock. And then coming off of there, we might have book 1 and book 2. So what about CDs? Let's do another example with this. What about CDs? What can we do with CDs that are not what can we do with CDs, or what values or variables and values do CDs have that aren't the name, the price, or the number in stock? And what can they do which isn't be viewed, be bought, or be used? So what other properties do CDs have? And remember, think quite basic. Yep, they can be played, although arguably that could be under used. Used is actually quite a broad category. But yeah, played. What else can we do with CDs? What other information do CDs have? Yep, the artist. Anything else that CDs have that you can think of? Yep. Storage size, especially if we're looking at blank ones. No one's actually picked. You're the first person to pick that up, Lewis. Well done. The pen is running out. Yeah, so storage. What else do CDs have? Let's say we're talking about a music CD. What else might CDs have that you go and buy in HMV? Begins with T. Good, tracks. And we can play them, which I haven't actually edited. So going back to our HMV stock, if we have CDs in part of our stock, I've got that up there, we would then have artist, we would have storage, we would have things like tracks, because usually at HMV we're not buying blank CDs, we are buying usually either music CDs or audiobooks. So we would have tracks, and we would also have usually a record company of some sort. In the case of audiobooks, a record company would be a book publisher, but CDs tend to have their publishers in terms of audiobooks recorded as a record company. And we can play a CD. So there is a second object that inherits this information, and these methods from the stock, adds these variables and this method, and then has objects of each of the different CDs. So CD1, CD2. And we could repeat this process right the way through, and we could carry on with this process for DVDs, we could carry on with it for vinyl, we could carry on with it for games, we could carry on with it, and we could do things like board games, t-shirts, collectibles, key rings, and anything else that they happen to sell in HMV these days. Given that, apart from the ones that you've told me, I'm kind of just making up what exists in HMV now. And then with that, we've got encapsulation of the books. We've got CDs, which are encapsulated in their own little bubbles. But what we also have is encapsulation on an even bigger level now, because all of the stock has its own encapsulation bubble, which is then broken down into these subclasses, which are encapsulations in themselves, because they have their own class and they have their own objects. And the inheritance is the passing down of the information from a class or a superclass, which might even be above that, into a subclass, into an object. And that's what it means by inheritance in OOP. Have I lost anyone with that? Put yes in the comments if you understood. And yeah, if you have any questions at any point in this, please put them in the chat and I will do my best to answer them within a timely manner as well, because this is probably more technical than stuff that you've done before, apart from possibly the database unit. So Declan, Freddie, are you still with us? Have we lost you? Are you still alive, Declan? Okay, I think we might have lost Declan somewhere down the way. Either that, or he's gone for a toilet break, or get a drink or something. Hopefully he's still alive and just not sitting at his computer at this exact point in time. Okay, so the other bit that we need to talk about in terms of sort of the main key features that really separate OOP out from procedural and event-driven programming languages is this idea of polymorphism. Now, polymorphism is basically the ability of an object or a class to change form depending on what it is being used with. And we've sort of already got that as a general idea, where we've separated out and we've got these different methods. So if we are looking at the class if we're looking at a book, so we're going to go back to the book class now. If we're looking at a book class in terms of it being in a store, you would probably have sell or buy as a method in a store. Now that looks like a H. Okay. As a method in a store for a book. But when you get the book home, it's changed from being an object that you would sell, and it's turned into something that you would read, or that you would open the covers or turn the pages for, or use as a doorstop, or burn. To be fair, you probably wouldn't burn a brand new book that you've just bought. You're probably going to burn something that you've been trying to learn stuff from the last eon as part of a course or something. But when you get it home, it changes. And if we look at burning, all of a sudden, that book, as soon as we start running a method for burning it, it stops being a book object, and it starts being great, I use this term like 20 million times a week and I've forgotten it. It stops being a book and it starts being fuel. That's the word. It stops being a book and it starts being fuel, because all of a sudden that book, by running a burn method, has ceased to be a book and has passed over and is now a fuel. At which point, fuel is a class, and we have things like, let's just put heat in there as an example, and the burn, which is the bit that manages the change from one type of object into another one. So there's our class, and book changes what it is from being a book class to being a book object of this new fuel class. And polymorphism is the idea. Oh, okay, screen is frozen. Thank you, Lewis. And polymorphism is this idea of an object behaving in one way and having one set of variables in one instance, and being and doing something completely different as soon as in another instance. So in a book class, one of these books is something that can be read, it can be opened, it can be turned into a doorstop, but it can also appear in a fuel class where it's the properties that were assigned to that book suddenly turn into the amount of heat that it gives out, and the amount of energy it gives out. That's literally the only things I can think of at this point off the top of my head, because I can't remember that much chemistry at this moment. And that book suddenly has two very different forms depending upon that use. So if you've understood what I've just said there about polymorphism, please put yes in the chat. I need to count 7 now, not 8. Let me see. Arthur, not expecting a from Jack. Petra, got Kieran, got Lewis, Freddie. That's who we're missing. We're missing Freddie. You all right with that? You managed to follow that bit? Okay, so that is basically the crux of object-oriented. Welcome back, Declan. That is basically the crux of object-oriented programming. It's that ability to take things, break them down, separate them out into different classes, and then different objects that inherit the traits from those classes, and different objects that can do different things depending upon what they are interacting with at any given time. And that's what makes it such a powerful way of programming, and it's also what makes it the most complex paradigm. It does, of course, have its drawbacks. Firstly, it does have a fairly steep learning curve. It's the most complicated of the programming paradigms. And as I said at the start of the last session, we're using object-oriented because that is the way that Unity and Unreal engines handle their coding. They actually code and allow you to set up code in an object-oriented fashion without needing to actually code all the bits that tell the objects to interact. It does the Unity engines and Unreal Engine actually do a lot of that interaction and a lot of the building of the classes for you. And all you actually then need to do is specify what the variables are and what the methods are. And you can do drag and drop onto different objects and just change the values for each object. And it's done in a more drag and drop and a more graphical way. Once you've got the basic setup of the class, you don't have to write each object out yourself with those. Easier to do error checking. It's also easier to get errors because it's a lot more complex, especially if you start looking at something that's quite a bit bigger. So we've looked at the stock aspect of HMV, but we might also, in a program that's being written for HMV, we might need to look at the staff. We might need to look at stores and store objects. I can't think of anything else off the top of my head, to be honest. So the programs themselves do get quite big and quite bulky because of using the classes and the objects. So they can take up quite a lot of space. They can also take a while to compile and to build. So when we were working before Christmas and we were doing that little program at Christmas, ouch, it didn't take that long to compile. It took probably long enough, but it didn't take that long to compile when we pressed the run button to test it to see how it worked. What it did do, however, what would happen with an object-oriented program is while we're building the program and we're editing the program and we're making changes, every time we click the build button, it has to compile everything and pull everything in from all of the different places, all the different classes, all the different objects every time. Once the program has been compiled and it is just a straightforward program that we run, it then does not take as long to load and to compile. And it can, once the program has been compiled and we run it, it will access the objects as and when it needs to, and not every time it is run as it does when it is being developed. And does that make sense? Have I lost anyone with anything today? Does anyone have any questions on what we've covered today? Right, if you have any questions, post them in the chat. If you don't want to post them in the chat with everyone here, hang around in the call till everyone's gone. If you are happy and you've understood what we've done, please comment in the chat. That it's just the usual yes, yeah, whatever you want to comment in the chat. And we now have a 1/4 of an hour break, and then we've got workshop time. No, I have got the right number of people. Right, so we'll end the session there. Obviously, what I've said has been recorded, and what I will do is